All right, all right, we're going to start looking at equations of lines. We've just been looking at the slopes of lines. We're going to start looking at equations of lines. And first, we want to get slope-intercept form for the equation of a line. We're going to have a few different forms for the equation of a line. Slope-intercept form looks like this: y equals mx plus b. When you see the equation of a line written in slope-intercept form, you're not going to see four variables like you see in this formula. X and y will be the variables. M and b will be numbers. And m is simply the number that's multiplied times x in that equation. And the reason we use the letter m there is because it turns out that whatever that number is, that is actually the slope of the line. And b just represents whatever your constant term is, and whatever your constant term is, that is the y-intercept for the graph of that particular line. It's where it hits the y-axis. So, and by the way, as we're going to, in a little bit, we're going to look at something called point slope form for the equation of a line. So there's a couple of different types of linear equations or forms we'll see them in. The way to keep this one straight is remember that slope-intercept form is the one where you have y by itself on one side of the equation, okay? So, okay, here's an example. Y equals 2x minus 3. Well, then right away you should be able to see that the graph of this equation is going to be a line, and the slope of that line is going to be 2. Because it's mx, our m is 2, then the slope of that line is 2. And minus 3. Well, that constant term, whatever that constant term is, that's your y-intercept. So just by looking at this equation, we know that the graph of this equation is going to be a line whose slope is 2 and whose y-intercept is negative 3. And so what I want to show y'all is the most efficient way to graph an equation like this that's in slope-intercept form. So you know how we could use the old T-chart with where we pick some x values and plug them in and find the y values that go with them and then plot those points and then draw the line through it and all that stuff. We don't need to do that at all if this thing is written in slope-intercept form. We've already got everything we need to graph this. First of all, we already know the y-intercept is negative 3. Y'all look, that means I can plot that point right away and say that that is the y-intercept. That's a point on the graph of that line, right? It hits the y-axis at negative 3. The slope is 2. Write that like a fraction. So in other words, 2 is the same thing as 2 over 1, right? Remember what the slope tells us? It's that delta y over delta x thing. And so what the slope is telling us is that if I'm at any point on the line that is the graph of this equation, if I'm at any point on that line, and this y-intercept is certainly a point on that line, remember the bottom number is left and right. Positive is right, negative is left. Well, it's positive 1. So if I go 1 unit to the right and the top number's up and down, and remember positive is up. So this says if I'm at any point on the line, like for instance this y-intercept, if I go 1 unit to the right and up 2 units, I'm going to hit another point on the line. Everybody see that? So I'm just going to go 1 to the right and I'm going to go up 1, 2, and I'm going to put a point right there. And that would be the point where, I'm going to go, 1 to the right and up 2, and that would be the point where x is 1 and y is negative 1. By the way, if you plug 1 in for x here in this equation, you're going to see that you get negative 1 for y, right? That's a solution to the equation. And by the way, technically that's enough to draw the graph, because now I could take my handy dandy ruler and just draw the line that passes through those points. But you know, I'm drawing freehand and not that good at it, so maybe I want to find some other points. Well, I could still just use this slope to keep doing that. From this point, I could go 1 to the right and up 1, 2. And that would put me at the point where x is 2 and y is 1. And that's another point on the line. Or maybe I want to find a point that's on the graph that's on the other side of the y-axis. Well, positive 2, the slope of this line is positive 2 divided by positive 1. It's also negative 2 divided by negative 1, right? So I could, if I wanted to, I could go back to this y-intercept, and if I look at the slope this way, that's still equal to positive 2, because negative divided by negative is positive. This says if I go 1 unit to the left and then down 2 units, I'm going to hit another point on the line. So I could go 1 to the left and down 1, 2. And that would be a point. That would be the point where x is, looks like negative 1, and y is as negative 3, negative 4, negative 5. Negative 1, negative 5. And you can see if I plug negative 1 into this equation in place of x, sure enough, I'm going to get negative 5 for y. So you need to get at least 2 points. Remember, we were given one of them because we can look at this and know the y-intercept. Then we can use the slope to find at least one more point. And because it's a linear function, we know the graph is a line. So then we just draw the line that passes through those points, and we have graphed that equation. Everybody see that? So super easy way to graph it if you've got the thing written in slope-intercept form. Let's look at one more example like that. So, so here's another equation that's given to us in slope-intercept form, and we want to graph this. So we know that our slope is negative 3/2 because it's whatever numbers multiplied times x. And we know that our y-intercept is 2 because the constant term is always the y-intercept. So the y-intercept is 2. That means that's a point on the graph. It hits the y-axis at 2. The slope is negative 3/2. Now here's the thing. When you write this, when you're going to use this slope to find another point on the line, there's 2 ways to look at that. One way to write negative 3/2 is to say that that's negative 3 divided by positive 2, right? The other way to look at that is to say that negative 3/2 is positive 3 divided by negative 2. It doesn't actually matter which you use because either of these is equal to negative 3/2. So let's say that I'm looking at this version where the slope is negative 3 over positive 2. That positive 2 on bottom says I'm going to go 2 units to the right. And then the negative 3 on top says from there I'm going to go down 3 units, right? So I'm going to go right 1, 2, and I'm going to go down 1, 2, 3. And there will be a point on the graph. And you can see that's the point where x is 2 and y is negative 1. And again, you can check that because if you plug 2 into this thing in place of x, the 2's cancel, you get negative 3 plus 2, which is negative 1, and that's your y value, right? At any rate, we got a point. Or maybe I want to get a point on the other side of the y-axis. Then I could use this other version of negative 3/2. And with positive 3 over negative 2, that says I'm going to go left 2 units. And then positive 3 means I'm going to go then up 3 units. So I'll go back to my y-intercept. I'll go left 2 units and up 1, 2, 3 units. And that would be another point. Looks like that's where x is negative 2 and y is 2, 3, 4, 5. Negative 2, 5. And, you know, I could keep doing that if I wanted to. Like if I wanted to find more points over here, I could use this again and go right 2 and down 3. Right 2 and down 1, 2, 3, wherever that would be 1, 2, 3. Somewhere right in there. That would be another point. But again, you need at least 2. And then just draw the line that goes through it, and there's my graph. Everybody with me there? By the way, notice that one had a negative slope, and sure enough, that line is falling from left to right. Everybody see how to do that? Now, what if we were given this equation and asked to graph it? Now, this is not in slope-intercept form. Y'all see that? It's not, it doesn't have y by itself equal to something with x. This one's a little different. You've got your x and y term together on one side of the equation and a constant term by itself on the other side. This form, which usually you'll see it written in sort of formula version like this, ax plus by equals c. In other words, you got something times x plus something times y equals some constant. That is called standard form. Standard form for the equation of a line. Now, slope-intercept form, the y equal mx plus b thing that we looked at here, what makes that such a good sort of way to look at equations of lines is because you literally just look at the equation and you immediately know the slope of the line and the y-intercept. Like when we looked at this one, we just look at the equation, we immediately know the y-intercept is -3 and the slope is 2. You can't really do this in what's called standard form, but standard form is the one where your x and y term are together on one side, constant term by itself on the other. If you wanted to graph this equation, I mean, probably none of you want to graph it, but if you had to graph this equation, there is a different way to graph it that's probably the easiest, fastest way to do it. So here's my advice. By the way, you could, I'm going to do this because I want y'all to see how to do this, because once in a while you kind of need to be able to. Let me show you what you could do. You could put this in slope-intercept form. Now you're going to have to do some work to get it there. And this is not how I recommend you graph this thing. If all you're being asked to do is graph this equation, don't do this. But you're going to see in the next section, once in a while, we need to be able to move things around here. What I could do is I could put it into slope-intercept form. If I was going to do that, that just means I need to move things around until I have y by itself, right? So I need to get rid of this x term, so I could subtract 4x on each side. And when I do, of course, those x terms that cancels, and I just get 2y equal 8 minus 4x, but let's say -4x plus 8. -4x plus 8. And then if I just divide each side by 2, do y'all see that's going to get y by itself? So I could divide each side by 2. That means you have to divide every term on both sides by 2. And I get y equals -4 over 2 is -2x plus 8 over 2 is 4. There it is in slope-intercept form. So now I can tell you that this equation, if you were to sketch its graph, the y-intercept of that graph is 4. And the slope is -2. And we could use that to graph it, right? However, we had to do some work to be able to look at it and see what the slope and the y-intercept is. This is my advice, because if you see a problem like this on the test and you're asked to sketch its graph, I'm not picky about what method you use to graph it, as long as your graph is correct. But here's the easiest way to do it. So that T-chart thing, I don't particularly like using this, but in this case, we're going to use it in a real efficient way. So we know that the graph is going to be a line, which means we need 2 points. We need to know 2 points on that line. Because if you're able to plot 2 points, then you can just draw the line that goes through them, and that's your graph. I want to find just only 2 points, but I want to be real efficient about how I do it. So here's what I'm going to do. First, I'm going to plug 0 in for x and find the y value that goes with it. Y'all look, if you plug 0 into this equation in place of x, what are you going to get for y? 4. Right. Who said that? Celine. And you saw that, I think, because I was watching Addie with her back trouble because I'm having the same thing. I was just thinking, man, I need to do that. Sorry. Y'all look, I don't think you wrote anything down to figure that out, did you? Or did you? Yeah, she didn't write anything down. She just said, look, if you plug 0 in for X, do you agree that 4 times 0, duh, is 0, right? So think of it this way. If you plug 4 in for X, you're just going to get 0 plus 2y, which is literally just 2y. Do y'all see that? And so if X is 0, the equation becomes 2 times y equals 8. And I'll bet everybody in the class knows that 2 times 4 is 8, right? So if X is 0, does everybody see that y has to be 4? And see, we didn't have to really do any math other than just a little bit of mental arithmetic to find that point. Now what I'm going to do for my second point, because I'm lazy, I'm trying to be as efficient as I can, I'm going to plug 0 in for y and find the x value that goes with it. So if I plug 0 in for y, what's the x value that goes with it? 2. Because look, if I plug 0 in for y, 2 times 0 is 0, and 4x plus 0 is just 4x. Y'all see that? So if I plug 0 in place of y, that equation just becomes 4 times x equal 8. And everybody in the class knows that 4 times 2 is 8. So x must be 2 when y is 0. Do y'all see that? And you see how easy it is to find those points? So anytime you're given the equation in standard form, where your x and y are together on one side and the constant term by itself on the other, plug 0 in for x. That makes that x term go away, and find the y value that makes that true. Then plug 0 in for y, which makes the y term go away, and you just get something times x equal a number, and find the x value that goes with that, and plot those 2 points. What's even better about this is, do y'all see that now I can look at what I've done and see that 4 is going to be the y-intercept for that graph? And do you see that if I just look at this, I know that the x-intercept of that graph is going to be 2? Because remember, every point on the y-axis has 0 for its x-coordinate. Well, this is the ordered pair 0, 4. Then 4 must be the y-coordinate, because that every point on the y-axis has 0 for its x-coordinate. This point has 0, it's its x-coordinate, so that's a point on the y-axis. Then 4 is the y-intercept. And every point on the x-axis has 0 for its x-coordinate. Every point on the x-axis has 0 for its y-coordinate. So I know that 2 must be the x-intercept, because 2, 0 is a point on the x-axis. Y'all see? And then all I've got to do is draw the line. So this way of graphing a line is sometimes called the intercept method of graphing a line. I mean, it's never really been called that by me, but it is called by that name in the book. So when you are graphing the equation of a line that's written in standard form, they may, in a homework problem, give you an equation like this and say, use the intercept method to sketch the graph. Well, the intercept method means you're going to plug 0 in for x and find y, and that's your y-intercept. You can plug 0 in for x, find y, and that's your y-intercept. You're going to plot that point. Then plug 0 in for y and find the x value that goes with it. That's your x-intercept. Plot that point and draw the line that goes through it. And of course, you know the x and y intercepts as well, which is sometimes information we're interested in. Everybody see this? So it's easy. Like I say, you could have moved this into slope-intercept form like we did here. Then you could have graphed it using what's usually called the, no, I don't know what that method's called. You could have, graphed it using the fact that 4 is the y-intercept, which we figured out a lot quicker and easier here, and then use your slope, which was -2, to go, for instance, 2 to the right and down 2 to the let's see, -2. I mean, 1 to the right, down 2, 1 to the right, down 2, like that. But it doesn't matter which method you use to graph. I don't care as long as it's the right graph. But when it's in standard form, this is the easiest way, fastest way to do it. Okay, another special case situation. Then we're going to start talking about finding equations of lines. So, okay. Sketch the graph of the equation y equals 3. And so y'all look, that's the most common wrong answer I get on this problem. And you're going to see something similar to one of these on the test, so make sure you're watching here. This is the most common wrong answer I get. It says y equals 3. So they just plot this point here where y is 3, right? But that's just a tiny piece of the graph. Notice there's no x in this thing at all, right? Think of it this way. It's like this is saying we don't care what the x coordinate is. We want you to plot the graph that shows every single point that has 3 for its y coordinate. Y'all see what I'm saying? So in other words, yeah, I agree. At that point, y is 3. But at this point, y is also 3, isn't it? That's the point where x is 2 and y is 3. Or at this point, y is 3. That's the point where looks like x is -5 and y is 3. And what you should see pretty quickly is this, kind of missed there, but this horizontal line, every single point on that horizontal line has y equal to 3. Do y'all see that? Like 3, 1, 3, 2, 3, 3, 3, 4. I'm sorry. 1, 3. I don't know why I keep getting my X's and Y's backwards tonight. Dyslexia or dementia. I don't know which is hitting me. 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 3, -1, 3, -2, 3, and so on, right? So anytime, so here's the moral of the story. Anytime you see an equation that just looks like y equals some number, the graph is always going to be the horizontal line that goes through this number, in this case 3 on the y-axis, right? So like if this asked me to graph y equals -2, right away I would know that it's this horizontal line that goes through -2 on the y-axis. Y'all see that? By the way, what's the slope of these lines? 0. They are horizontal. All horizontal lines have a slope of 0. You remember how we talked about slope-intercept form, y equals mx plus b? Well, do you agree that y equals 3? This is what I'm about to do is a really dumb way to write y equal 3. But do you agree that if I wanted to, I could say that y equals 3 is the same equation as y equals 0x plus 3? Slope is 0. Y-intercept is 3. Sure enough, the slope is 0. It's got to be a horizontal line. And the y-intercept is 3. It's the horizontal line that goes through 3 on the y-axis. Everybody see that? Now, I wouldn't write it this way, y'all. Obviously that's much easier. But I just wanted you to see that technically y equals 3 could be written in slope-intercept form. It's just the slope is 0, right? Hence, we're going to have an x term. And then finally, the equation x equal -2. So when we graphed y equals 3, we saw that that was a horizontal line. So what do you think is going to happen when we graph x equal -2? Yeah, it's going to be a vertical line. And it's just like what we did a minute ago, except this time we don't see y at all. And so what it's kind of like this equation is saying is it doesn't matter what the y coordinate is. If the x coordinate's -2, we need to see that point on the graph. Well, there's a point where x is -2, right? Specifically, that's the point -2, 0. Well, there's -2, 2. There's -2, 3, -2, 4, -2, -1, and so on. And what you should see pretty quickly is if I draw this vertical line, which I'm not doing very well, that goes through -2 on the x-axis, that's going to be the graph of x equal -2. Everybody see that? So every single equation that just looks like x equals some number, the graph is going to be the vertical line that goes through that number on the x-axis. By the way, what's the slope of this line? Undefined. The slope of all vertical lines, any vertical line has undefined slope, which literally means sometimes you'll see it, and they may even do it in this book. They'll say that line has no slope. That's true because remember, if it had a slope, that means you could have m equal, you'd have some number here and you don't. But I don't like saying no slope because to me, it's like, I'd rather just think undefined. In other words, I can't assign a number to the slope because the slope doesn't exist, and therefore I know it's a vertical line. So something I would mention to y'all, remember back to last Wednesday, and we were talking about that vertical line test. Y'all remember that? That says when you have a graph that if there's a way to draw a vertical line where that single vertical line hits the graph more than once, it's not a function. So do y'all agree that, for instance, this horizontal line does represent a function? Because no matter where I draw a vertical line, see, I hit the graph once. I hit the graph once. The y-axis is a vertical line. It hits the graph once. No matter where I draw a vertical line, I only hit the graph once. Here's a line that's rising from left to right. Do you agree that that line represents a function? Because it passes the vertical line test. No matter where I draw a vertical line, see, I only hit the line once. That vertical line only hits the line once. Lines that fall from left to right, if I had one falling from left to right, it's going to represent a function because look, I draw a vertical line, it only hits the graph once. There's no way to draw any vertical line that hits the graph more than once. What about this graph? The graph of this equation, x equal -2. Is that the graph of a function? No, because in fact, there's one vertical line that hits this graph more than once. It's specifically this vertical line, and in fact, it hits it at every single point, right? So vertical lines are sort of the most not function you can possibly be. Like not only do you have two ordered pairs with the same first coordinate, every ordered pair has the same first coordinate. Y'all see that? And consequently, or maybe not consequently, but along those same lines, remember we said even this weird looking thing y equal 3 that doesn't even have an x in it, you could still think of it, of writing it in slope-intercept form. This one you can't. There's no way to write this in slope-intercept form. Because in slope-intercept form, you have to have y, right? You can do away with x because maybe it's 0 times x. But if it's 0 times y, that just means there is no y, right? So the point is, this one, you couldn't write it in slope-intercept form if you wanted to. That's because this kind of equation is different. It's not a function, right? Okay. So if we're given the equation of a line, we can figure out what the graph of that line looks like and sketch its graph. So then the other thing has to be, if instead of being given the equation of the line, instead of giving the equation of a line, what if we're given some information about the graph of the line and asked to find its equation? So here's an example, and we'll kind of talk about what we need to do to be able to find these. So find the equation of the line with slope equal to 3 that passes through the point 2, 1. Now they haven't given us the graph, but they've given us all the information we need to find the graph, right? Because I could plot that point 2, 1, and if the slope is 3, which is 3 over 1, I could go from that point 2, 1 to the right and up 3, and that would be another point, and I could plot that point and draw the graph, right? So they haven't technically given us the graph, but they've given us information about the graph. They've given us enough information to be able to sketch the graph, so we know that this information is enough to find the graph. Is it enough to find the equation that would be the graph of? And so this is where a new form for the equation of a line is going to come in. So far we've seen that standard form, ax plus by equals c. We won't need that for this. We've seen y equals mx plus b. Remember, that's slope-intercept form. We're going to need this simply because when we find the equation of a line, we always want to write our final answer in this slope-intercept form. But now we're going to pick up another form for the equation of a line. It's called point-slope form. Point-slope form for the equation of a line. And here's what that formula looks like. I don't know why I just wrote that all down, because I had it all already written down here, but oh well. Point slope form. Y minus y1 equals m times x minus x1. This also looks kind of awful because it looks like I got y, y1, m, x, x1. Looks like there's 5 variables there or something. There's not. X and y will be the only variables. Here's what point slope form is. So you know how this is slope. So let me write it, because it helps you, I think, if I write it to see this. So slope-intercept form, y equal mx plus b is slope-intercept form. It's called slope-intercept form because you can literally just look at this equation and know the slope just by looking at whatever that number is, m, that's multiplied times x, and you can just by looking at the equation, you know the y-intercept. It's whatever that constant term is. Well, this one's called point-slope form, which means that in point-slope form, you should be able to just look at the equation and immediately know a point. In other words, an ordered pair, an x and y coordinate that represents a point on the line, and the slope of that line just by looking. So here's what that is. M is the slope. X1 and y1 are the x and y coordinate of some point that's actually on the line. So if we look back up at this problem here, we are given enough information here to write the equation of the line immediately in point-slope form. They tell us that the slope of the line is 3. So here's the information we're given in the problem. The slope is 3. And it passes through the point where x is 2, y is 1. And that's what we're going to use for the x1 and y1 in this formula. Y'all see that? So x1 is simply the x coordinate of some point that's on the line, that the line passes through. Okay, they gave us an x1, 2. y1 is simply the y coordinate of that same point. And of course, they gave us that y coordinate, the point 2, 1. So 1 is the y1. So I can write this equation in point-slope form immediately. Y minus y1, that's going to be y minus our value of y1, which is 1, equals m, well, that's given in the problem, 3, times in parentheses, x minus x1. Well, in our problem, x1 is 2. Everybody see this? So 3, that's our slope that was given in the problem. 2 here was our x1, right? I just plugged our value of x for the ordered pair that we were given, representing a point on the line. I just plugged our value of x in here in place of x1, and I plugged the value of y that we were given in here in place of y1. So when you do these problems like this in the homework, in the 2-3 homework, they're going to say, find the equation of the line with slope equal 3 that passes through the point 2, 1, and they'll say, find the equation of the line in point slope form and slope intercept form. Well, we are done with the first part of that problem. This is the equation of the line in point slope form. Y'all see? And it's that easy. You just write it out based on whatever the slope and point was you were given. Everybody with me? Okay. But now they want us to write it in slope intercept form. To do that, all we really need to do is I want to simplify this. I'm going to multiply. I'm going to distribute this 3. And then I'm going to add 1 to each side. Why? Because remember, slope intercept form is the one where y is by itself on one side of the equation, right? So I'm going to distribute this 3. 3 times x is 3x. 3 times -2 is -6. And then I'm just going to add 1 to each side. So when I do, I get y equals 3x. -6 plus 1 is -5. So y equals 3x minus 5. And there it is in slope intercept form. Everybody see that? So here it was in point slope form. We literally just wrote it out in point slope form based on the information they gave us. Then once you have it in point slope form, distribute the 3 over here, distribute, and then whatever this number is subtracted from your y term, move it to the other side. Now you've got it in y equals mx plus b form. So now you can see that the equation they're talking about up here, the equation is y equal 3x minus 5, so the graph is going to have a y-intercept of -5, and the slope is 3. And of course, we know that 2, 1 is a point on the line because they gave us that, and you could instantly graph it, right? I mean, we've already got enough to graph it. Now we know the equation that would be the graph of. Y'all see that? I don't think I want to do the, yeah, no, I don't want to do that. Let me do a similar one because there's something else I want y'all to see. Hang with me just a second. I changed my mind. Hang with me just a second. I'm kind of doing this on the fly. I'm gonna get myself straight. So you got -4. Okay, so I think so 2. Let's see. 8 will be. Okay. Sorry that took so long, but I just realized I wanted to do an example like this instead of like the one I kind of had set up. Okay. So first of all, as we do these, y'all are going to see me writing this a lot. This is, you can see from the problem we just did, FTEOTLPT, find the equation of the line passing through these points. I just get tired of writing that over and over again, right? So that's just my shorthand for find the equation of the line passing through the points -4, 3 and 8, -3. So notice this is different. Like in this first problem we did, we were only given one ordered pair that represented one point on the line. but we were given the slope of the line, right? And we saw that when we were given that, we could write the thing in point slope form right away. That's exactly the information we need. This time we were given not one, but two ordered pairs that represent 2 points on the line, but we were not given the slope of the line. Do y'all see that? Well, again, to write this thing in point slope form, we can't write it in point slope form without knowing the slope of the line. We weren't given the slope of the line. So do y'all see that we're going to have to use that slope formula to find the slope of the line, right? So remember, slope is y2 minus y1 over x2 minus x1, right? And so we have our x1 and y1 and our x2 and our y2, and I'm just going to plug them into that slope formula. So y2 minus y1 is going to be -3 minus 3, -3 minus 3. -3 minus 3. What's your signs there? Then x2 minus x1 is going to be 8 minus -4. 8 minus -4. And so -3 minus 3 is -6 over 8 minus -4 is really 8 plus 4, which is 12. And -6 over positive 12 is -1/2. Everybody see that? You know, we would simplify that, reduce the fraction. 6 goes into 6 one time, and 6 goes into 12 two times. And of course, negative divided by positive is negative. So now we know that our slope is -1/2. And we have a point that's on the line. Since we've already labeled this one x1 and y1, -4, 3. Then now we have the information we need to write the equation in point slope form. Everybody see? Because now we know the slope, we use the slope formula with the 2 points we were given to find the slope. It's -1/2. And we have an x1 and a y1 that was given in the problem. That we can use -4 as our x1 and 3 as our y1. Everybody with me? So now I'm just going to plug it in. Y minus y1, that's going to be y minus 3, equals m, which is -1/2, our slope, times in parentheses x minus x1. That's going to be, now be careful here. Y'all look where I'm pointing. If you're looking down at your notes, look up where I'm pointing. Do y'all see that x minus x1 is going to be x minus -4? And I'm just going to go ahead and write that in simplified form. That's really x plus 4, right? You got to be careful about that. But there is our equation of the line in point slope form. That's the first thing the homework's going to ask for. But now we got to put it into slope intercept form. Again, I need to distribute the slope here on the right side, and then I'm going to need to add 3 to each side to get y by itself. So first I'll distribute. -1/2 times x is -1/2 x. And -1/2 times positive 4 is -2, right? So I get y minus 3 equals -1/2. Sorry, y'all couldn't even see that. So -1/2 times x is -1/2 x. -1/2 times 4 is -2. And so now I just need to add 3 to each side to get y by itself. And so I get y equals -1/2 x. -2 plus 3 is +1. So I get y equal -1/2 x plus 1. And there it is in slope intercept form. Y'all see that? So when you do these problems where they're asking you to find the equation of the line, most all the time, they've got to ask it to you in one of those two ways. Like this one, we could do this problem. This is like the first one of those we did. They've given us the slope and they've given us a point on the line. By the way, this is the same problem as this one. I just Notice the slope's -1/2, and that's a point. I just gave the problem using the different information because I wanted you to see it. But they either have to give us the slope and 1 point, or if they're not going to give us the slope, they have to give us 2 ordered pairs, 2 points, which we then could use those 2 points to find the slope. Then we could use the slope along with either one of these 2 points to write the equation in point slope form. Everybody with me there? Yes.
Why did you put the ordered pair of -4 and 3 beside the slope of -1 over 2?
Why did I use them here?
Above.
Here?
Yeah.
Well, because I'm thinking about what's the information I need to be able to write the equation of the line in point slope form. I know I got to have the slope. Well, now I have it because I found that. And I know I got to have a point on the line. I actually had 2 to choose from. I just chose this one mainly because that was the one I'd already called X1, Y1.
Okay, so it doesn't matter.
No, all I'm saying is once we find the slope, we've got to use that slope along with one of these points to write the equation in point slope form. I just wrote it here to say, okay, here are the 2 pieces of information we're going to use to now write that equation of the line.
When you put that
No,
beside it, I thought that was like.
no, this is, first of all, this isn't the answer to what we were asked to do anyway, right? We're asked to find the equation of the line. This is just the information we need to be able to write that equation of the line. Does that make sense? And by the way, you could have just as easily used 8, -3 instead of -4, 3.
Right.
Let's say we had done it that way, that we found out that our slope was -1/2, just like we did by using the slope formula. But let's say instead of using this point -4, 3, what if we used the point 8, -3 and use that in our point slope formula instead? It shouldn't matter. If I do that, I'm going to have y minus y1. Now this time you got to watch your sign because of that y coordinate, right? It would be y minus -3, which is really y plus 3, right? And that's equal to m, which again is -1/2, times in parentheses x minus x1. Well, now we're using this point, so that's going to be x minus 8. And so there's the equation in point slope form. Now, something I want to show y'all real quick since we've done this. When we use the other point, here was our point slope form. Y minus 3 equals -1/2 times in parentheses x plus 4. Here I used that second point, and my point slope form, the equation in point slope form is y plus 3 equal -1/2 times in parentheses x minus 8. Do y'all agree that these look different, right? This is one of the things I don't like about point slope formula, and it's the reason that really we never use it, except we use it as a way to figure out what the equation is in slope intercept form. Because notice point slope form for the equation of a line is not unique. You know, whatever that line is, it has infinitely many points on it, right? And every one of those points is represented by an ordered pair. And any one of those ordered pairs, if you use it in the point slope formula, is going to give you a point slope form for the equation that looks different than all the others, right? But here it is in point slope formula in form. By the way, if this problem were in the homework would accept either one of these answers as point slope form because they're both right. They look different, but look what happens when we put this in slope intercept form. So I need to distribute that -1/2. -1/2 times x is -1/2 x. -1/2 times -8 is actually +4. And then I would need to subtract 3 on each side to get y by itself. And when I do, I have y equals -1/2 x. 4 minus 3 is 1, so +1. And there it is in slope intercept form. So notice The point slope formulas look different, but in slope intercept form, it's exactly the same, right? It doesn't matter which point you use in this point slope formula. You know, if you're given more than 1 point, like we were in this problem, doesn't matter which one of them you use in the point slope formula. The point slope form will look different based on which ordered pair you used. But if you just move it around till you get into the slope intercept form, it always looks the same because there's only one way to write it in slope intercept form. Everybody see that? Okay. So we can find equations of lines. And that's what we're doing throughout section 2.3. Section 2.4, we're still finding equations of lines. And there's really not much new information that we're given in that section. The main new information we're given in section 2.4 are these two little factoids. And so the first one says that two lines are parallel if and only if they have the same slope. So remember, when we say that two lines are parallel, it means, you know, that they run side by side forever and never intersect. They never cross each other. Everybody see that? Well, everybody knows what parallel lines are, right? That they kind of run side by side forever. They never intersect. And does it make sense that if two lines never intersect, they're parallel, and if they never intersect, if they're parallel, they have to have the same slope? Do y'all see that? The reason is, remember, slope measures how steep a line is. It measures whether it's rising or falling and how steep it's rising or falling. Well, let's say that you had two lines and they had almost the same slope, but just a little bit different. One line was just slightly steeper than the other. Well, do you agree that if you just kept following these lines forever, they would eventually intersect, right? Which means they're not parallel. So obviously, if two lines are parallel, that means they never intersect. And if they never intersect, that must mean that they rise or fall at the exact same rate, right? Their slopes are the same. So two parallel lines have the same slope. The other little fact is that two lines are perpendicular if and only if their slopes are negative reciprocals. So I will talk about what that actually means. So let's say that, maybe I can steal one of these. Let's see what I can do if I steal this thing. Let's say that has a slope of 1 up 2, right 1 and up 2, left 1 and down 2, down 2. I'm going to try to show you what's happening with perpendicular lines. If you're just going to hang with me a second here. And so then if you had one that had a slope of -1/2, that means you go left 2 and up 1, left 2 and up 1, 10 on 1, or you go right 2 and down 1, right 2 and down 1. Okay, so I have maybe this is a way I can show you what's happening with perpendicular lines. So when we say that lines are perpendicular, we mean they cross at 90-degree angles, right? So for instance, probably the most famous set of perpendicular lines are the X and Y axes themselves, right? Where they cross, it's 90-degree angle. It makes a perfect square corner where they cross. Okay. So here I have tried to draw two perpendicular lines. Let me zoom in just a little bit here. Okay. So these lines are perpendicular. In other words, where they cross right there, that makes a perfect square corner there where they cross. Everybody see that? Okay, so let's check these lines out. Let's look at this one first. We'll call it line 1. if I were to check out its slope, I could actually do that, I think, because I could say, okay, to get from, say, this point to this point. Well, to do that, I would go 1 to the right and up 1, 2. So I went up 2, that's my delta y, and then I had gone 1 to the right. So I went 1 to the right, that's my delta x that goes on bottom, and I went up 2, that's my delta y that goes on top. So line 1 has a slope of +2. Do y'all see that? Okay, let's look at, we'll call this one line 2. So line 2, let's see what's happening with it. In fact, that point's also on line 2, so I'll just start there. In that case, if I wanted to say get to this point on line 2, so we're going to find the slope of line 2, I would have to go 2 units to the right. Remember, that's delta x that goes on bottom. And right is positive, so 2 units to the right, so delta x is +2. Then I would have to go down 1 unit. Do y'all see that? And that's negative. Down is negative, so I'd go 2 right. That gives me a delta x on bottom of +2. Then I would go down 1. That gives me a delta y on top of -1. So the slope of our first line is +2/1. The slope of our second line is -1/2. Do y'all see that? These lines are perpendicular. Their slopes are negative reciprocals of each other. So when we say that numbers are negatives of each other, it means they have opposite signs, right? When we say that numbers are reciprocals, we mean that one is the other flipped over. Everybody with me there? So these numbers are negatives of each other. This one's positive and this one's negative. They have opposite signs. They're also reciprocals. Do y'all see that? The first line has a slope of +2, or 2/1. The second line has a slope of -1/2. 2/1 and 1/2 are reciprocals. +2/1 and -1/2 are negative reciprocals. They're reciprocals that also have opposite signs. Everybody see that? So perpendicular line slopes are always negative reciprocals. So in other words, if you know the slope of one line is, well, let's see, maybe I've got a problem here we can do. Yeah, we'll do a problem and I'll show you what this means. We'll try to do one of each. What's our time like? I think we've got enough time too. So we're going to look at a couple of problems where we're finding you're going to see that we're doing the same stuff we were doing in 2-3. The only thing that's different is they've added another little wrinkle. So now this problem says, find the equation of the line passing through the point 2, -3 that is parallel to the line given by this equation. So here's the equation of a line, y equals 2/3 x minus 2. That's not the equation we're looking for. We're looking for the equation of a line that's parallel to this one, but that passes through the point 2, -3. So we know that to find the equation of that line, we need to be able to write that equation in point slope form. And we know that if we can do that, we've already seen that all we have to do then is shuffle it around, distribute and get y by itself to write it in slope intercept form. Well, I have an x1 and y1. In other words, I know a point that's on that line. It's the point where x is 2 and y is -3. We can use that for our x1 and y1 in the point slope formula. But what are we going to use for the slope for m? Say again? 2/3? Yep, so this is what you got to see. That first problem we did, they just gave us the slope of our line and gave us one point that was on the line. And we could write the equation in point slope form right away. The second problem like that we did, they didn't give us the slope of the line, but they gave us 2 ordered pairs, which gave us a way to find the slope of the line, right? Well, this time, technically, they did not give us the slope of the line. They didn't give us the slope of our line, but they gave us a way to find the slope of our line by saying, look, the line you're looking for is parallel to the line that has this equation. Oh, well, that means then that whatever the slope of this line is, that must also be the slope of my line. Do y'all see that? Well, this is y equal mx plus b form. So the slope of this line is 2/3. Our line's parallel to that one, so the slope of our line must also be 2/3. Do y'all see that? So now I know the slope of my line is 2/3, and I know that the point 2, -3 is a point on my line, so that's my x1 and y1. So now I can find the equation. I can write it in point slope form, y minus y1, that's going to be y minus -3, which is really y plus 3. That's equal to m, which we now know is 2/3, because we've got to have the same slope as this line since they're parallel, times x minus x1, that's going to be x minus 2, our value of x1. So there it is in point slope form. Now we got to move it into slope intercept form. So I have to distribute this 2/3. Now, some of y'all won't like it because there's fractions here, but this isn't terrible. First of all, 2/3 times x is pretty straightforward. It's just 2/3 x. 2/3 times -2 is -4/3. And y'all look, if you have trouble, like, we multiply fractions, it's always nice if the denominators cancel, but they just don't here, right? But you just multiply. 2 times 2 is 4 on top, and 3 times 1 is 3 on bottom. And of course, it's positive 2/3 times -2/1. So it's negative. Okay. That's not terrible, but we still have to get y by itself. So I have to subtract 3 on each side. And of course, on the left side, that's easy. They just cancel. I just get y. But on this left side, I actually have to do this. -4/3 minus 3. When you're adding or subtracting fractions, if one of them's a whole number, an integer, it's actually easy because I can write any integer with any denominator I want. So I've got -4/3. I'm trying to subtract 3. What number would I have to divide by 3 to get 3? What number do I divide by 3 to get 3?
1.
9? Yeah, it's like I didn't ask it in a good way. I should have said, what number divided by 3 is equal to 3? Does everybody agree 9 divided by 3 equals 3? The reason I'm saying that is, do y'all agree that 3 is the same thing as 9 divided by 3? And so -3 is the same as -9/3. So when I have to do this addition, where I'm actually adding with fractions involved, I can just say that 3 is the same as 9/3. And -4/3 minus 9/3 is -13/3. And there's the equation of the line in slope-intercept form. Everybody see how to do that? So, yeah, I know, we wound up with some fractions, but oh well, it is what it is. -13/3, which would be at -4 1/3. That's where the y-intercept is. And the slope is 2/3. And notice, if you look at the equation of the line, let me zoom back up a little bit. If you look at this, it's parallel to this line. Yep, it is, because they both have the same slope. And of course, then the thing, if we want to make sure this was the correct equation, first we could say, well, they got the same slope and they're supposed to, because my line's supposed to be parallel to this one. Then the other thing you'd need to do is plug 2 in for x here and see if you get -3 for y, right? If you really want to check your work. And if you do, if you plug 2 in for x, you get 4/3 minus 13/3, which is -9/3, which is in fact -3. That's right. So the point I'm making is, I know the arithmetic got a little messy because of the fractions, but this is just like the problems we've been doing. The only difference is now, instead of literally telling you your slope is 2/3, you have to be able to look at this and go, oh, duh, the slope of that line's 2/3 and mine is parallel to it. So They didn't tell me the slope is 2/3, but the slope is 2/3, right? Finally, this will be our last problem tonight. And I think, it'll almost be our last problem tonight. Then I got one thing I got to show you just to help you with one homework problem, and that's it. Okay, this is kind of what we just did, except two things are different. First of all, this time, instead of parallel, we're looking for a line that's perpendicular to some line whose equation is this. The other thing is, notice this equation they've given us is not in slope-intercept form. Y'all see that? It's not got y by itself. It's also not in that standard form that we talked about a little bit earlier. Remember, standard form would be if it had x and y on one side and this constant term were on the other side. But it's not that either. Do y'all see? Every term's on one side and it's equal to 0 on the other side. This is what this author calls, this particular author, good old Robert Blitzer, calls this general form for the equation of a line. And here's what he says general form is. AX plus BY plus C equals 0. In other words, general form just means not only do you have your X and Y terms on one side, you've got every term on one side and 0 by itself on the other side. I can only surmise that this is called general form because it's generally useless. You're going to find that every single time we see something in general form, a linear equation written in general form, the first thing we're going to want to do is shuffle stuff around and get it into some different form. So I don't really understand why he uses this. The problem is I couldn't assign enough homework problems to give you practice in 2.4 if I didn't assign 1 or 2 where this kind of thing pops up. So I want to show you how to do this. When you see this problem in homework, it'll say find the equation of the line in point slope form and general form. Like for some reason, he gets really eaten up with general form. I'm going to tell you, we're going to find the equation of the line we're looking for here in point slope form and slope intercept form, just like we always do, for 2 reasons. One, because I'm always going to ask you for slope intercept form. Like on the test, I'll expect you to write your answers in slope intercept form. 2, because once you write it in slope intercept form, it's real easy from there to put it into this, what he calls general form. But here's the thing. We're going to have to go backwards to go forward, because I can't, by looking at this equation, I can't just look at it and figure out what the slope of that line is. Y'all see? Like this isn't in the form where I just look and go, oh, y equal mx plus b, m, that number is my slope. I don't know what the slope is. And so you're going to see why I say general form is generally useless. The first thing we're going to have to do is get this in slope intercept form so that we can see the slope of that line. And so I told y'all this earlier that we would need this tonight, and here we are. We've got to move things around here until we have y by itself. So y'all look, because I'm going to do a couple of things in the first step. I'm going to subtract x on each side, and I'm going to add 2 to each side. That's what I'm going to do first. Subtract x and add 2. Just that'll get the y term at least by itself, right? I'll have negative 7y equals, well, 0 minus x plus 2 is just negative x plus 2. And now I just need to divide each side by negative 7. Y'all see? And by the way, negative x is the same as negative 1x. I just say that because some of you, it'll help you to think of it that way. Now I need to divide each side by negative 7. And so when I do, I get y equals, I got negative 1 over negative 7. That's just positive 1/7 x plus 2 over negative 7. So that's just minus 2/7. So again, that's kind of messy looking, but doesn't really matter. What it tells us is this equation that they've given us here, the slope of that line is positive 1/7. Y'all see that? Does everybody see what we did there? Because you got to be able to do this for a couple of the homework problems in 2.4. You've got to be able to move your x term and constant term to the opposite side. And then whatever this y term is, you got to divide everything by that y coefficient to get y by itself. So now we can see that the slope of this line is 1/7. So what is the slope of our line? Now remember, our line is perpendicular. Our line is perpendicular to this line whose slope is positive 1/7. So what's the slope of our line? -7. So remember, that's right. Remember that perpendicular line slopes are negative reciprocals of each other. So y'all look, this equation they've given us, its graph is a line, and the slope of that line is positive 1/7. If our line were parallel to that one, then positive 1/7 would be our slope. But our line is perpendicular, and that means its slope is going to be the negative reciprocal of positive 1/7. So negative means reverse the sign, so make it negative. Reciprocal means flip it over, so instead of 1/7, it should be 7/1. Does everybody see that that is -7, right? So now we've got a point, 9, -5. That was given to us in the problem. We can use that as our x1, y1. Now we know the slope is -7, so y minus y1 is going to be y minus -5, which is really y plus 5. That's equal to m. Well, now we know our m, our slope is -7 times, in parentheses, x minus x1, that's x minus 9. So now we've got the equation written in point slope form. Now they're asking for general form, but here's what we're going to do. We're going to just go ahead and put it in slope intercept form first, just like we've been doing. A, because you need to practice that, because that's what I'll ask for on the test. So -7 times x is -7x. -7 times -9 is positive 63. And now I need to subtract 5 on each side. When I do, I get y equals -7x. And then I got 63 minus 5, is that 58? So plus 58. So there it is in slope-intercept form, which again in section 2.3 is what he's asking for. In 2.4, if it's a problem like this, he's going to ask for it in general form. But here's the thing, we can fake him out, and it kind of makes me feel good to do this too. Remember, general form just means you've got all the terms on one side and 0 by itself on the other. Do y'all see that all I would have to do here is subtract y on each side? So that on one side, y'all can see I'm going to get 0. And so what I've got here is -7x minus y plus 58 equals, well, 0. And that's what he's calling general form. And so there are, I think, maybe like 2 problems where he asks for that, okay? And so that's the way you step through it. First, he's going to give you an equation in general form. You need to put it in slope-intercept form so you can figure out the slope of that line. Then if you're looking for something that's parallel to it, that's going to be the slope of your line. Or in this problem, you're looking for something perpendicular to it. The negative reciprocal of that is the slope of your line. Go ahead and find point slope form. He's going to ask for that. But then he asks for general form. But just go ahead and put it in slope-intercept form. That's good practice. That's what you'll need to do on the test anyway. And then to answer his question of general form, just subtract y on each side. And that's going to give you an acceptable version of general form. Everybody see that? Let me real quickly do this problem because this is the last thing in 2.4. It's not on the test, but there's a couple of homework problems. I want you to know how to do it. It's this business of finding average rate of change. And this is, again, one of those that shows up here simply because they know that some college algebra students will take calculus. And this is an idea that really pops up in calculus. But all this is slope. This is literally just slope. So here's what it says. Find the average rate of change of this function f of x, which is equal to 4x minus 7, from x1 equal 2 to x2 equals 3. Here's what they're asking me to do. They're asking me to plug, y'all look, I've got x1 equals 2. They're asking me to plug 2 into this function and find the y value that goes with it. Then our x2 value is 3. So then I'm going to need to plug 3 into that function in place of x and find the y value that goes with it. So let's do that first. So first we're going to find f of x1. In other words, we're going to plug our value of x1 into this function. So it's going to be 4 times 2 minus 7, and that's 8 minus 7, which is 1, right? So that gives us a point where x is 2 and y is 1. And notice that x1, that 2, they're calling it x1. Then I'm going to call 1 the y value that goes with it. I'm going to call that y1. Y'all see? Then they say that x2 is equal to 3. Well, then now I'm going to find f of x2. In other words, now I'm going to plug 3 into this function. So that's going to be 4 times 3 minus 7. And that's 12 minus 7, which is 5. And so now I see that when x is 3, y is 5. And so they told me that 3 is my x2, then 5 is my y2. Y'all see? So all they did is they gave me a function. Y'all make sure you get this. They gave me a function, f of x equal 4x minus 7. And they gave me 2 x values, 2 different x values to plug into that function and find the y values that go with them, right? So in other words, when they gave me 2 different values of x, they gave me a way to find the 2 different values of y that go with those. And so essentially, I now have 2 points that are on that line, right? Or 2 ordered pairs that are solutions to this equation. When they ask for the average rate of change, they now want me to find the slope of the line that connects these 2 points. That's it. And so we're just going to use the slope formula. Slope is y2 minus y1 over x2 minus x1. And we're just going to plug these numbers in. So y2 minus y1 is 5 minus 1 over x2 minus x1, that's 3 minus 2. Well, this is a pretty easy one. 5 minus 1 is 4. 3 minus 2 is 1. I get 4 over 1, which is 4. So 4 is the average rate of change of that function between the x value 2 and the x value 3. So that's all you're being asked to do. Now, let me tell you why you're doing it. Just because, again, so you know that there's a reason why they do stuff like this. If you find the slope of a linear equation, that's how fast the line grows. Like 4 over 1, that means that every time in this function, every time x gets 1 bigger, y gets exactly 4 bigger. It doesn't matter what x value you're at. If your x gets 1 bigger, your y is going to increase by 4. But not all functions increase at the same rate all the time, right? If you have a function whose graph looks something like this, for example, well, that's a function. It passes the vertical line test. But notice when you go from, say, x equal -1 to 0, from this point to this one, notice x went up by 1 from -1 to 0, but y barely went up at all, right? On the other hand, if you look out on this end of this graph, maybe we're here and here, see this time x went up by 1, x went up by 1. See here when x went up by 1, look, y went up by that tiny little amount right there. This time when x went up by 1, y went up by a much bigger amount. Y'all see that? So the point I'm making is not only linear functions grow at this constant rate where you can say the slope tells you how fast the line is growing. So this average rate of change thing is sort of like the baby introduction to coming up with a way to take functions that are more complex, whose graphs aren't just simple lines, and start trying to talk about having some sort of language to talk about how this particular function is growing at any particular value of x. So that's the only reason we're doing it. But all y'all have to do on the problem is plug the two x values in, find the two y values that go with it, and then find the slope of the line that passes through those points. When you see those average rate of change questions at the end of 2.4, that's all they're asking you to do. Okay, that's all I got. We're certainly out of time. Let me go back here. I'm going to stop recording.